the precipitation reaction occurs, and the formation of precipitate does not involve any complex steps like other reactions. Here, when two aqueous solutions with different ions are mixed, the positive and negative ions exchange themselves. That is nothing but it is termed as double displacement. There is a displacement of ion taking place. Again, a new compound which is formed, it is being one of the compound is being insoluble in the solvent or the aqueous media. Hence, it comes at the bottom. That means the solid particles gather and settle out of the liquid, forming the precipitate. That settled down insoluble solid is known as precipitate, and these are the steps involved in the formation of precipitate. So, it is very important to know whether all the compounds that undergo reaction form a precipitation reaction or leads to the formation of precipitate. No, there is some rules and regulations where the compound follow themselves to form to undergo in the precipitation reaction. That is nothing but the solubility rules. Here you can see two different columns with their own rules and regulations for the soluble ions and insoluble ions. The soluble ion column include alkali metal, that is group 1A, like sodium, potassium, lithium, etc., along with ammonium ion, nitrates, acetates, chlorates, perchlorates, and also when we talk about halogens, it is chloride, bromide, iodide with metals. In the case of halogens, there is some of the exceptional cases, that is F minus fluoride ion, silver, lead and mercury, and all the metals forming sulfates are the soluble ion. Exceptional cases are barium, strontium, calcium, lead, silver and mercury. So this is all about soluble ion. Since these all are the soluble ions, they are soluble in the aqueous media, and that they does not form any kind of insoluble solid material, or they does not form precipitate, to be very specific. Now moving on to insoluble ions. All the metals forming sulfides except calcium, barium, strontium, magnesium, sodium, potassium and ammonium are the exceptional case. In the case of sulfide, hydroxide, there is a spelling mistake, please note it down, hydroxide, all the hydroxide ions are insoluble ions. Here the exceptional cases are the hydroxides of alkali metals, that is group 1A, larger members of group 2A starting from calcium 2 plus, including transition metal, aluminium and ammonium. Again moving down, carbonate, oxalate, chromate, phosphate are also insoluble ion. Exceptional case are group 1A and ammonium ions. So, since these all ions comes under insoluble ion, that means they are forming the insoluble solids in the reaction. Insoluble solid is nothing but the precipitate. So all the ions present in this column forms the precipitate, whereas all the ion present in this column does not cause any type of precipitate, hence they form the aqueous media. When we look into the example here, you can see that AgCl is in the solid form and NaNO3 is in the aqueous media. So here all these ions comes under the aqueous media, whereas all these ions comes under the insoluble solid or the precipitate media. So in order to understand the solubility rule in a very brief way, let us consider an example of potassium fluoride in the aqueous media is being reacted with strontium nitrate again in the aqueous media, giving rise to strontium fluoride, that is the insoluble solid, and the potassium nitrate in the aqueous media. Here it is very clear that strontium fluoride is being precipitate in this reaction, because when you look into the column here, the fluoride ion belong to the exceptional case of soluble ion, which means they are forming the insoluble solid, nothing but the precipitate. Hence, here the strontium fluoride is being called the precipitate of this precipitation reaction. So when we look into this NO3, that is nitrate, here nitrate belongs to the column of soluble ions, which means they are soluble in the aqueous media and they does not form any kind of precipitate. They form the aqueous solution in the reaction. So let us look into another example. Ammonium perchlorate is being reacted with sodium bromide, giving rise to sodium perchlorate and ammonium bromide. In this case, the solid and the aqueous media is not being mentioned here, because when you look into this column, here the perchlorate is being belong to the soluble ion column. Again, the bromide ion is being belonging to the soluble column, to the column of the soluble ions. Since both perchlorate and the bromide ions are soluble ions, there is no case of formation of precipitate in this kind of reaction. Therefore, it is termed as there is no kind of reaction, or there is no kind of precipitation reaction taking place over here. So, it is very clear that not all the compounds form the precipitation reaction and not all the reaction form the precipitate. So the main thing to be when the reaction is to be precipitation reaction is there should be the formation of precipitate. So in here, in second case, there is no formation of precipitate since perchlorate and bromide are soluble ions. Hence this reaction cannot be considered as a precipitation reaction. So in order to understand how quick or how instantaneous the precipitation reaction and how the precipitate is formed when the two compounds or in the aqueous media are mixed, there is a visual representation so that you could understand it in a very brief manner. Precipitate, the curd-like substance that was formed when the ferric chloride is mixed with sodium hydroxide. The ferric hydroxide is formed, that is the brown precipitate formed in this precipitation reaction. So here, when you look into the column, the hydroxide ions belongs to the column of insoluble ions. Insoluble ions in the sense they are forming insoluble solid, nothing but the precipitate. Hence, the ferric ions are being reacting with the hydroxide ions